Okay, this next concept is probably one of the most important foundational concepts to understand and become comfortable with in Introduction to Statistics. And that is the concept of a z-score. A z-score is a value on a z-scale. So to kind of understand what a z-scale is, I want to connect it with something or some things that you may have already seen that you can relate it to in order to help you better understand what a z-scale is and what a z-score can represent, and also to help you feel a little more comfortable in approaching it and working with it. So let's look at, the definition of converting from one data scale to a different data scale. And so the formal example I have here is converting temperature from degrees Fahrenheit to degrees Celsius. So degrees Fahrenheit, is what we in the United States use to measure temperature. The temperature outside, the temperature of our bodies. When we are feeling sick, we put a thermometer in our mouths, we measure our body temperature, and 98.6 degrees Fahrenheit is to be a normal, average temperature, body temperature. But the rest of the world uses degrees Celsius instead to measure temperature. Well, if I'm 98.6 degrees Fahrenheit, there should be an equivalent measurement in degrees Celsius that also describes my body temperature accurately. So two different temperature scales describe the same amount of heat. So I'm going to use that first as a formal example, and then I'll give another one that I think will be a little more simpler, which may help too. So first, let's look at the analogy between Fahrenheit and Celsius. So to convert from the Fahrenheit scale to the Celsius scale, we use this equation here. So notice that degrees Celsius is all by itself on one side of this equation. So we would consider this to be our output. And Fahrenheit is kind of buried within an expression on the right-hand side. And so we would consider this to be our input. So if we input degrees Fahrenheit and we simplify the expression on the right-hand side, simplify this expression, then what we'll be left with will be the equivalent degrees centigrade. And that's how we do the conversion. That's how we convert a unit of degrees Fahrenheit into a unit of degrees Celsius. What we're doing is we're actually just taking a value on the Fahrenheit scale and we're translating it to a Celsius scale. Okay, now that's going in that direction. Now, what if we wanted to go in the opposite direction? We wanted to convert from degrees Celsius to degrees Fahrenheit. So notice that now degrees Celsius is our input and degrees Fahrenheit is our output. And the expression looks a little bit different. These two functions mathematically are what we would call our inverses of each other. All right. So let me, show you kind of like a visual of this representation here. So here across the top, okay, we've got the Fahrenheit scale. And so here's the Fahrenheit scale on this number line. So we've got 0 degrees Fahrenheit and 100 degrees Fahrenheit and so on. And down below, we have our degrees Celsius scale down here. Okay, so we've got 100 degrees Celsius, and so on. So if we wanted to convert degrees Fahrenheit into degrees Celsius, okay, we're going to be going in this direction. And to go in that direction, we want Fahrenheit as an input, and we will use this equation. So that'll convert a value from degrees Fahrenheit into degrees Celsius. Now, if we wanted to convert 32 degrees Fahrenheit, now 32 degrees Fahrenheit is the temperature at which water freezes. So what is that temperature that water freezes in Fahrenheit? What's the equivalent temperature in the Celsius degrees scale? So what we can do is we can take 32, we can plug it in as an input here into degrees Fahrenheit. And when we simplify the expression on the right-hand side, 32 degrees Fahrenheit converts to 0 degrees Celsius. So 0 degrees Celsius is also the temperature at which water freezes. All right, now we can do that again. So if we take well, let's leave it. Okay, well, if we take the temperature at which water boils, which is 212 degrees Fahrenheit, so this is the temperature at which water boils, and this would be at sea level. That's 212 degrees Fahrenheit. And if we plug in 212 degrees Fahrenheit into our equation and go in this direction, that would convert to 100 degrees Celsius on the Celsius scale. All right. Now, what if we wanted to go back? What if we wanted to take degrees Celsius and convert that into degrees Fahrenheit? So for example, on this scale here, let's say we had 250 degrees Celsius. We want to convert that into degrees Fahrenheit. Well, what we would do is we would take 250, plug it into our input into this other equation, simplify the expression on the right, and 250 degrees Celsius would convert into 482 degrees Fahrenheit. So 250 degrees Celsius converts into 482 degrees Fahrenheit. If we were to pick another temperature like negative 100 degrees centigrade, we would take negative 100, plug that in to our input here, and when we calculate degrees Fahrenheit, that'll come out to negative 148 degrees Fahrenheit. So negative 100 centigrade converts to negative 148 degrees Fahrenheit. So you can see that we have two completely different scales, and we can kind of interchangeably go back and forth between them using inverse functions. Okay, but we can use it using these two equations. So that's one example. You know, and if you've taken chemistry or physics or a natural science class, you know, you may have seen something like this. But something that maybe might be a little bit more recognizable than this would be converting between inches and centimeters. Right? So instead of units of temperature, this is units of length. Okay, so you know, 0 inches would also translate to 0 centimeters, right? 0 length in inches is equal to 0 length in centimeters. But what if we wanted to convert 1 inch into centimeters, or 2 inches into centimeters, 3 inches into centimeters, 4 inches into centimeters. How do we do it? Well, the equation we would use is that the number of centimeters is equal to 2.54 times the number of inches. So that'll help us convert from inches into centimeters. So notice that inches is the input. Okay, that's what we're putting in. And centimeters is the output. That's what's coming out. So if we plug in 1 inch into our equation, then 1 times 2.54 will be 2.54. So 1 inch is equivalent to 2.54 centimeters. And we can do the same thing with 2. So if we put 2 inches in, so we plug 2 into this equation, 2 times 2.54 will give us 5.08. Right? Okay, so 1 inch converts into 2.54 centimeters, 2 inches converts into 5.08. If we do the same thing with 3, we take 3, we plug this into that equation. 3 times 2.54 will give us 7.62 centimeters. And if we take 4 and plug that in, 4 times 2.54 gives us 10.016, keeps going, centimeters. All right, and we could just keep going to our heart's content, converting inches into centimeters, but I think you get the idea. Now, if we wanted to go back the other way, okay, so this is the equation we used to go from inches to centimeters, but now we want to go from centimeters up to inches, then the inverse function for that is going to be the number of inches is equal to the number of centimeters divided by 2.54. So this will help us convert from centimeters over to inches. Notice now that centimeters is now our input and inches is now our output. So for example, if we wanted to convert 9 centimeters, 9 centimeters, that might be somewhere right about there, then we would take 9, plug it in for C for centimeters, take 9 divided by 2.54, and that would translate to 3.54 and some change inches. All right, so I think maybe this idea of converting from one scale to another is something that you're already have been exposed to. And I think it's something that you can relate to. If you've seen this thing with Fahrenheit and Celsius before, okay, this will be recognizable. If you haven't seen it before, welcome. Now you've been exposed to it. If you take chemistry or physics, you'll see something like this. But if you haven't, you've probably converted things from inches to centimeters. This is kind of like a basic setup between converting between 2 different scales. And that's all we're doing with a z-score and a z-scale. Okay, so if you're trying to keep this idea in mind, let's now see how that figures into converting any data scale to a z-score. All right, so what this allows you to do is take any kind of quantitative data and convert it into a z-score scale. So to convert from any data scale to a z-score scale, you use either If you're dealing with a sample, okay, then you're going to use this equation. And if you're dealing with a population, then you're going to use this equation. And notice that these two are, very much the same. The only thing that's changed is the relative variables, that refer to a sample versus a population. So for example, one of the differences here is here we've got a sample mean because we're dealing with a sample, but here we've got a population mean because we're dealing with a population. Likewise, down here in the denominator, we've got a sample standard deviation because we're dealing with a sample. And here we've got population standard deviation because this is in regards to a population. So this equation here, is very similar to the equation that we used to convert Fahrenheit into Celsius, except if we wanted to convert Fahrenheit into a z-score, we would use this equation. If we wanted to convert inches into a z-score, we would use this equation. Okay? And so this is kind of what I mean about converting any data unit into a z-score. So, if this scale up here was in degrees Fahrenheit, perhaps, and we wanted to convert degrees Fahrenheit into a z-score, okay, on the z scale, then we would use this equation. Likewise, if we had a z-score and we wanted to convert that back into the scale with units in it, we would use this inverse function right here. So one thing to notice is that, this scale up here is the scale of our datums. So for example, if we were looking at a data set of temperatures, okay, and we had negative 112 degrees Fahrenheit, negative 50 degrees Fahrenheit, 121 degrees Fahrenheit, 300 degrees Fahrenheit. Okay. These values here, these are kind of like our values of X. Okay. And so these values of X are the input for this equation. So that would be values that are on this scale. Okay. And when we put that X in and we simplify the right-hand side of this equation, what do we get? We get the output, which is our z-score. And that gets mapped over to this scale down below. Now, notice that when I used these examples here previously, okay, there was only one variable on the right-hand side. There was only one variable on the right-hand side. We only had one input. Okay, but notice now, this equation has two other inputs, right? It has the mean and it has the standard deviation. So these things, if they're not given to you, might be something that you have to calculate, okay? But whether they're given to you or you calculate them, you'll put in some value of X and you're going to convert that value of X into a z-score. Now, what's a little different here is that because you're using the mean and standard deviation in this equation, remember that the mean, that is our measure of center. And since the mean is a measure of center, and we're taking values of X from our data set, and we're taking this value and we're subtracting it from the average, right, of that data set, we're going to get the distance between this datum and the average. And then we'll take the next one, and we're going to take the distance between that datum and the average. So what ends up happening is that whatever the sample mean or the population mean is, like in our datums and the units that they're in, whatever the mean or the sample mean or the population mean is, that'll get converted to a zero on the z-scale. So a zero on a z-scale represents the sample mean or the population mean, the very center of the data. And you'll notice that the z-scores, are +1 to the right, -1 to the left. So these are values relative to the center or the mean of your data. So that's where, this conversion of units takes on a statistics angle, um, is because we're using these properties of statistics to do our unit conversion. And the center of the z-scale has a value of 0, and that is the value that coincides with our sample mean or our population mean. Here I converted degrees Fahrenheit into a z-score. I could convert, um, measures of inches, like 27 inches, 39 inches, 47 inches, and so on. I could convert that also into a z-scale. Just about anything else you could convert into a z-scale. And so notice that a z-scale is unitless. Okay. So let's kind of review these notes that I've got regarding conversion into a z-scale. The mean and the standard deviation of the data must be found first. Okay. It has to be found first because you need to use it in order to simplify the right-hand side of this expression. The part that I just mentioned is that the mean of the data becomes the 0 of the new z-score scale. Okay, that's what I was talking about up here. Yeah, and part C is I'm just kind of verbally describing the right-hand side of this expression. So I don't think I need to comment on that at the minute. All right, so what we've seen is I've given some concrete examples here, okay, with these units and converting to a z-score. And I've actually done, a little bit of the calculation here to show how you do it. All right. But let's look at an example now and see how we can do that conversion on the calculator, okay, to help make this a little easier. You know what? I'm going to save this for another video. Let me go ahead and stop right here. We'll do this example next. Okay, let me know if you have any questions.